Steel is steel, electricity is electricity. You negotiate a good price, you buy what you need and move on. But compute is not really a commodity. It's a lot more complicated than that, and that is the misunderstanding, and it's an expensive one. Before we get into this week's video, I wanted to let you know that at the moment we're in the middle of a crowdsourced funding round. Now, the crazy part is that I'm not allowed to advertise that raise outside Australia, but nothing stops me posting information about the raise to keep the community updated. I wanted to tell you this because a few people have said in the comments, hold on, what's all this businessy stuff? I'm just here for the tech. And that's fair enough, but I do need to explain that the crowdsourced funding round is really important for us. You might be surprised to learn that at the moment, I pretty much do everything on this channel myself. Of the small amount of advertising money that we've made from YouTube, I've been able to rent some better equipment, but we've also allocated a part of the money that we hope to raise to reinvest into this channel so we can make more videos with the whole team and share more of our journey with you. If you'd like to learn more, please check out our website. Thanks again for watching, and now on to this week's video. We call chips silicon because that's what they're made of, but the value isn't in the substrate or the material, it's in the design. Different chips can be designed for different things, and engineers can build a chip one way for one task and it works great, but you use it for something else and it sucks. So why would a company that already designs one of the most successful chips in history for the iPhone go and design a separate family? Now, cynics might say it's marketing, but the real reason is that they were designed around different constraints. The A series was designed to run on an iPhone with no fan, running on a battery that has to last all day, held against a human face. Every watt that it draws comes at a cost because people will complain if their phone gets too hot. But an A series chip is designed to work exactly the way people need phones to work. But most people don't hold their laptops to their face. They don't hold their iPads up to their faces either. So you can't just take an iPhone chip and scale it up to work with a laptop. You need to think about how people are using those devices and the kind of performance they expect. The A series chips in the iPhones is a 15-year lesson in doing more with less. But the M series on a Mac is a much shorter lesson about doing more with more. The key difference comes down to memory and cooling. In a conventional AI machine, the processor has its own memory and the graphics card has its own memory. To run a model, you have to copy data across a bus from one pool to the other and back again. The graphics memory is small and expensive, so when the model is too big, you have to split it across multiple cards. Then you need to put cards in a network, put in cooling, and build an electricity substation. That's one way to deliver AI, but it's not the only way, and I don't even think it's the best way. For the vast majority of AI use cases in our daily lives, the Apple approach is far better. That's because Apple Silicon shares one pool of memory across the entire chip. The processor, the graphics, and the dedicated neural engine all pull data from the same place, and that's called unified memory. I've made a few videos to explain that already. Now, at that time, everybody else bought their chips off the shelf from suppliers who sold the same silicon to every competitor. That was the cheaper and easier approach, which made it very sensible for every phone maker to do that. But Apple realized that it needed to design its own instead, and then spent the next decade solving some of the hardest problems in consumer electronics. The problem is that our phones don't have fans, so you can't rely on cooling. You also have a battery, so you can't give it more power. The phones also have glass with people hold against their ears, so you can't let the glass get too hot, otherwise it'll burn people. Not cool, if you pardon the pun. But with every release of the iPhone, they worked on making the phones more and more efficient, doing more and more with less energy and less heat. But somewhere along the way, Apple added a dedicated engine for AI inference. Not because they wanted to make cat videos, but because they wanted a fast way that you could open your phone with your face or process a photograph. And to do that, you have to have advanced AI processing on your device. You have to do it really fast, and you can't drain the battery. So on-device AI is not a new idea at all. It's been in your pocket for the best part of a decade. Most people didn't even notice. That's because it was never sold as artificial intelligence. It was sold as a camera. Then in 2020, Apple took the next logical step and put the same idea into a laptop. When people ran the benchmarks, they were blown away. I was blown away. A thin laptop with no fan was competing with workstations that had power supplies the size of a house brick. Everybody by surprise because the whole industry just assumed that computers only needed CPUs, and if you wanted video games, you bolted on a GPU. Apple broke the mold by making the CPU and GPU on the same chip, but then it made one step further and added a neural engine in between. That when large language models became an enterprise question, there was already a machine on the market that could handle AI comfortably on device, drawing less power than a kettle in an office that didn't require special cooling. So let me be clear that chips are not just silicon wafers. They're like engineered cities with highways and train lines that allow data to move around quickly. The more efficiently that traffic moves, the less congestion, the less heat and frustration. I'm Dr. Earl Brandt, the founder of Kiraa. If you enjoy my videos, please like and subscribe. To learn more about what we're building and get involved, jump on the website and sign up for the newsletter. Connect with me on LinkedIn, and I love reading your thoughts in the comments below. Thanks again for watching, and I'll see you in the next one.